Okay, so in 7.5 we are solving trigonometric equations, and there are a lot of examples because it seems like the only way to explain it is to show you an example, and they keep changing, you know. So, all right, so we're going to look at this example 1. I will talk about the terms up at the top, but first I'm going to show you this example, what we're talking about. So it says find all possible exact solutions, and that wording all matters, for the equation cosine theta equals 1/2. So what we're really doing is we're saying we want to solve this equation. When is the cosine equal to 1/2? Now, we've done stuff like that before when we were doing inverse functions. So it's a little bit different the way they're wording it here. Think about your unit circle, and where is the cosine 1/2? Well, in the first quadrant, right here at pi over 3, the cosine of pi over 3 is equal to 1/2. So that would be an angle then that has a cosine of 1/2. Okay, so there's one. But if I were to go all the way around to here, I would also get a positive cosine in the fourth quadrant, and that would be the cosine of 5 pi over 3. 3 equals 1/2. Okay, so this one's 5 pi over 3. Okay, so you say, oh, okay, well, there's two answers, pi over 3 and 5 pi over 3. Well, that's if you're just going around the circle one time. But if they say all possible, that means we're not just going around one time. We're saying all the possible solutions. So we could keep going around this circle again. So we could go around and to there. So that would be another period, another 2 pi. So we could have the answer pi over 3 plus 2 pi. And then we could go all the way around the circle and then over to here. So that would be 5 pi over 3 plus 2 pi. So these are answers. And then you could say, well, couldn't you go around the circle again? Yep. So we have a way, though, of writing that. And the way we do it is we say, okay, here are the solutions. Pi over, oops, let me change this. Here are the actual solutions. Pi over 3 plus or minus, because you could go around the circle in the other direction, 2k pi. Now let me make sure they put the k there. Yeah. Okay. And what we're saying is k is an integer. All right. So you could go around once around the circle, twice around the circle. You could go in the other direction. And then we do the same thing for 5 pi over 3. Plus or minus 2k pi. And again, where k is an integer. They're not always probably going to put that in the answer. They're just going to assume that we know k is an integer. That's when we want all possible solutions. Okay? So you have to add this idea of, well, there's lots of solutions because we know the cosine curve, you know, it keeps going and going and going, right? And there's lots of places where the angle would get, the cosine of the angle would be 1/2. So to represent that, we have this 2 pi or 2k pi to, you know, show all the periods. Okay? And you might say, well, that's interesting. That's great. You know, it's a little bit of work there to add in the 2k pi, you know, but I can do that. They don't always want that, though. Sometimes they'll say over a specific interval. And quite often they will say, all right, 0 is less than or equal to theta is less than 2 pi. So in that case, we're just going one time around the circle. And in that case, for this particular problem, you would only have two answers, pi over 3 and 5 pi over 3. Okay? So you'd have pi over 3 and 5 pi over 3. Now this problem didn't say that. They said find all possible exact solutions. So they want the one I put the box around. But if they had specified an interval, then you go by that. So it has to do with the domain, and they can specify that. We want it to be over this domain. And sometimes that changes. Quite often you'll see it for one trip around the circle, but we will show you that as we do more examples. Okay? So it has to do with specifying the domain and what they're asking for. Are they asking for all possible solutions or just over a particular interval?